Okay, so uh, I would like to start today's class with the symmetry. So actually what we have done so far in the course book, it's still chapter 1 actually, so we are still in the fundamentals of mathematics, which includes the numbers, some equations, also I think we have learned about the circles, and then later we see how to write down the linear equations and so on and so forth. After the chapter 1, I would like to review chapter 2, which is actually about function, but since most of you are, we have another subject of functions in calculus, so I would like to make a quick review. So yeah, I think that's the chapter 2. And chapter 3, which is we are going to have the polynomials. Okay. So hopefully today I can take some review, most review on functions and get some introduction on polynomials. But if not, then maybe focus more on the functions. So this is another way to see or to observe the symmetry. Okay? So symmetry, we can check the symmetry. Okay? If the symmetry is, like for example, I think this is pretty common, y equal x squared. You have symmetry along this y-axis. So the left and right, they are the same structure. And we can actually see from several times here that if we would like to say it's symmetry with respect to the x-axis, it means that we can replace y with minus y, okay? And they need to be equivalent, okay? They need to be equal. And for the second one, we can replace x with minus x. For example, y equal x squared, okay? Both x and minus x, they have the same value of y, okay? And another one is, we say this is symmetrical with respect to the origin. So you can imagine that this will be like this part here, it will be symmetrical to this part, okay? So we can think this origin, you are symmetric or reflecting this part to this left and then reflecting to the y minus, okay, y minus. So from xy to here and then here, or you can replace this negative x and negative y, okay? And then it's precisely having the same structure, okay? All the same distance within the x and y axis. Okay, so that's the symmetry, okay? And then another interesting on these line equations is about slope, okay? Let me write here, this is slope of line. Do the other day read the announcement about this class? Okay. Yeah, it's Saturday. So Saturday is by default like no class. But I think because our class, there are many. I think it's 2 or 3 times, 2 times holiday, right? So I think we need a class, at least one additional. Okay, so remember there's a slope what is actually slope? A slope is, you can think slope like for example, we start from the horizontal like this. Okay? The slope is when we are taking this line and then changing a little bit with some angle. Then this is our slope, or we can say the slope is increasing, which means that if this is 0, then this is a positive slope. Okay. Now, what's happened when we have this? This is actually, we can think like a negative theta. Okay. You can think within the concept in radians in the trigonometry. When you are moving your axis or your line counterclockwise, you are getting positive angle. When you are rotating the axis clockwise, you're getting negative angle. And to get to know the slope, you could directly use the, so imagine this is a triangle. Okay. So this is y, this is x. Okay. So we could say the tangent of the theta, this is y over x, okay, which is similar to what we have here. We have rise over run. Okay. But I would like to just give you the concept within the trigonometry, which is the same concept that we can use everywhere whenever we see linear equation, and we can say, okay, I know the slope, okay, directly from the ratio between the with all this triangles concept. Okay. And this tangent theta, because this is, if we think like in the system of the trigonometry, this should be positive. But tangent negative theta, this is equal to negative tangent theta. Okay. So this is another way to grasp your all concept that that actually they are the same. Okay. So you think in trigonometry, you think in the linear equations, or you think in calculus, they are the same. Okay, they are the same. So again, this is the slope. So whenever we have something like this, it's a positive slope, negative slope, and then this is zero slope. This is no slope. Okay? But I would like to say later on, in calculus, you will see something like this. If we use limit, okay, if we use limit, let me write here. Just to let you know, okay, what this is about.
Okay, sir. This PPT is already on model?
Not yet.
Not yet.
Not yet. So this no slope means if using limit, slope is, let me write quotation, it's infinity. Okay. So later, okay, I think in calculus, you can imagine like from this slope, and then you increase, and if you getting closer to vertical line, it's actually getting to infinite numbers. And if we are using limit in calculus, if you say this is actually infinite, then the numbers is getting large and large. But for now, we can say there's no slope. Okay, we can say there's no slope because the slope, if we are not using any limit concept, will be undefined. Okay, so basically, slope is rise over run. So, which means that we can also see from different points like this, okay? And their slope are the same. So every ratio between these two triangles, we can take the equations. For example, this y2, y1. Okay, we can make that happen else also. So if we know the point, we can know the slope. Okay, I think that's quite easy. So we could say that from here we can also write as m, or the gradient is y minus 1, and then over x minus x1. So we can rewrite this in terms of linear equations, which is so if the question is asking, for example, find line equation through (3, -4). So we have 2 points now. So we have 2 points. So what we can do, we can use these 2 methods. Okay? We can use these 2 methods. We know that the difference between y and x, the delta, right? Delta y and delta x, and we know the slope, right? We know the slope, then we can imagine take this point or this point, and then we can take that into our random y and x. If you're still not familiar how to get the line equation, you can start by making a coordinates. Okay? So imagining the points. Okay? So for example, let's say we are getting the points first. Okay? So -1, 2 is this, -1, this is point, okay? And 3, -4. So let's say that's our line. So this will be -1, 2, 3, -4. So we can start by taking the slope, which is -4, -2, 3, -1. So we can have -6 over 4, which is -3 over 2. And then let's say we take that maybe point here. Okay? Let's say this is any point that's b, x, y. Okay? And use this point to make another slope formula. We can take the either the first one or the second one. So let's say the first one. So we can have y minus 2 over x minus -1. And this should be equal to -3 over 2. Or we can write in terms of the line equations, like x plus 1, like that. Okay? Or we can write using the second point, so y plus 4 and x minus 3. So we can solve this. So let's say we multiply by 2. So 3x plus 2y minus 1. Okay, and then this part also the same. -3, okay. Oh, this is 8, sorry, this is 8. So y, 2y plus 3x, -1. Okay, the same, right? So no matter in each point you pick up, you will get the same formula, which is, this is the line equation for the line, okay? Okay, and then from the same concept, we can make the slope formula, which is, I have it right here. So let me put here first. So we can take the y mx plus b. What does it mean? Okay, what does it mean? So when x is equal 0, y is equal b. So what does it mean? So, for example, if I have this line, like randomly like that, and I said that this will be y mx plus b. Now this point here will be 0b. Okay, so you get the intercept of the line equation directly when you have x equals 0. So a graph for every linear equation, so general equation of line. We have ax plus by plus c equals 0, and a, b not 0. And I think that's it for the general formula. Another additional information is, if you have these two lines like this one, they have different equation, but they have the same slope. Okay, they have the same slope. Okay, we say that this is what we call a parallel. Okay, this is parallel. So this will be parallel line, meaning they have both have same slopes. So we can say that M1 equal M2, okay? Another condition that might happen is this one. So if this is happen, this is getting the 90 degree over there, we say that this is the condition for perpendicular. Sometimes they called it orthogonal, the same thing. This will be M2 equal -1 over M1. Or we can see that M1
multiplied by m2 is equal -1. We can check this theory using the triangle, the Pythagorean formula from this part, this distance, and this distance. So we can check this through the distance of OA squared plus distance of OB squared. This should be distance of AB squared. And then I hope you can prove this part. Okay? But the conclusion is this. Okay, I think most of the part we finished. So this is all the fundamental for chapter 1. Okay. Okay, so let's move on to the next chapter, which is the function. But since I think I taught functions a lot in calculus, so I will just do some quick review, okay? So the content's the same with the calculus one. So I would just like to remind some parts that need to be emphasized. So what is function? So function is a set of rules. Like if you have this machine F, you put some X and it will give you the different output, okay? And if we look at here, if you have two different input, it can be the same. It can be the same. You may have that, but the same input, it should be having one, right? One output. So if it is having two outputs like this one, it's not a function. Okay, and I think I also give you the idea how to check the functions through the graph by taking the vertical line directly. So if you have this graph, okay, and taking this line, you will see that when you plug in A, there are 2 points here, which means that this is not a function. A function, suppose that we are always talking on the single variable function. So y is supposed to be function of x, supposedly, and by default we are assuming that this is always the case, okay? Because you may encounter a graph like this in different cases, okay? Either using multivariable, or if you are having the parametric equation, which is not a standard y equal f of x. Right? Like I think in physics you have a graph of the positions, and then from that positions you get the velocity, and then you get the accelerations, and so on and so forth. And that is using parametric, but it's not a standard y-axis axis.
But if we are assuming that all the functions we are going to discuss, they are actually single variable y equal function of x. Okay, and then another important thing is about domain and range. Okay, so domain is every possibility for the x value for some functions. Okay, for some functions. I think I give you some cases, like for example this part here. So the case that mostly for every questions in math, in calculus, they're asking you about domain. There are only 3 cases. I think we don't have like more than 3 or combination between these 3. Everything that's related to the form of three cases. The first one is you have 1 over something below. You have square root or any even number of square root of the roots. Okay, so you have something inside. And the last one is you have the log or the ln or log. Okay? And you have something inside. Okay? So this is actually a shortcut, but I hope you understand what I mean. Okay, so you have this bottom one here that you need to have this everything inside should not be equal to 0. Okay, and this part here, everything inside must be greater or equal, at least equal to 0. And for the log, this should be greater 0. Okay, only these 3 cases that is going to make trouble, okay, finding domain. So like for the first one here, you see 1 over x squared minus x. So that means that the x squared minus x should not be equal to 0, or x minus 1 should be not equal 0. So x is not 0 and x is not equal 1. Okay. And directly the second one, you get the 9 minus x squared, and this should be greater equal 0, or x squared is less equal 9. Now sometimes, like I think every time I mention in inequality, sometimes you make mistake, okay? Whether it's less, greater, equal. Okay. So what we can do, we can just take it just equal, finding the x value first. So we have 2x value, and then put into the line numbers, and then check the possibility. So we could take this into x squared minus 9. Okay. So we could take this, factorize to see whether we can get the conclusions. So we check 0, it's negative. Yes, it's negative. So we would like to have the x squared minus 9 less equal 0, right? So we check again the other part. For the greater than 3, it's positive. And for the less than negative 3, we can check negative 4, which is negative, and negative, it will be positive. So it will be this part. Okay. But if you already know and already familiar, then you could go directly. Write that the
the domain is between the -3 and 3. And don't forget that we need to include, okay? If you write the domain just like this, then this will be wrong. Okay. I think the last one, the third one, is combination between the square root and then one of the reciprocal, okay? Which means we need to combine both of them. So here, this part here need to be t plus 1, need to be this, okay? So we are not equaling it to 0 because it cannot be defined, right? So t is, okay, I think we finished. There are some sections about the graph, getting information from the graph. I believe most of us knows that and already familiar, which means it's just testing the x to the functions and put into the point in the graph. I think that's easy as that. Okay, now this is just I think the same with what we have in calculus. How to represent a function? We can use the words, we can use formula, we can use graph visuals, we can use tables. Okay, and these all are functions. Okay, how to represent a function? But so I think we can skip this one. And some functions that is, I believe, important includes the linear, which we, I think, discussed before, the power functions, the root functions, reciprocal functions, and absolute value. So if you look at this, okay, and if you already learned before about the inverse, you can see the inverse between power and root. Okay. Notice that we missed something here and also here. Why?
Because it can be negative. It can be the integer.
Yeah, root can be negative. Or we could say, if we look here later on, you see that this is actually not one-to-one functions, which is we need to select only this part or this part that need to be taken as inverse. Okay, I will let you know later about the inverse. And this one is one-to-one functions, not one-to-one, one-to-one. So every not one-to-one, we need to restrict the domain so that we can have the inverse. Okay, and then we have the reciprocal functions, which is 1 over x with power of n. We can have 1 over x like this, 1 over x squared, 1 over x cubed. And you will see that every even number in the power, it will have the, like this one. Okay. So it means that the negative one is not included, right? Because of the square root. And another important function is the absolute value. And then there are another unique function which we call the integer, the greatest integer function. So the greatest integer functions is, if you look at the page that we have here, it's like a stairs. Okay? It's like a stair. So it says that the integer, you know the integer, right? 0, 1, blah blah blah. Okay. So every greater, the greatest integer in between of the numbers, like for example 0, 1, we take
we take the greatest number, and then we include that, and then we take the 1, and then we get the other one, and then we get 2, 3. Okay, so it's like jumping like that, and they are not connecting with each other. Okay.
Okay, I think that is. Okay. Okay, so let me give you example how to solve the equation by graphs. Okay. So the first one, the second one, and we have the third one. Okay. So try to think this equations and inequality. So if we would like to solve this based on the graphs, okay, so we can think this as two different equations. Okay. So we can think the left one is like, for example, f, the right one is g. So we can write that f of x, we can think as 2x squared plus 3, and g of x is 5x plus 6, which these two we can draw, at least we can try to draw easily, right? So let's say the f of x is like that, and then the 5x plus 6 maybe around here, okay? So
The first one, actually you can solve it finding the exact point, these 2 points here, by solving this and then finding the x, find the x solutions. You can try to, if we can factor it, we can factor, or if not, then maybe directly use the quadratic formula or making a standard equation. But what happens if we would like to solve this? We could try the same thing, and then solving it with the line numbers, and you get the interval, right? But if we would like to solve based on the graphs, okay,
we can think like this, okay? So the first one
is when we have the f equal g, okay? So which means that the solution is exactly on this point, these 2 points, okay? Which you can get from solving the quadratic equations, okay?
Or if you have the second one like this, this one should be the f of x less equal g of x.
So we have 2 different graphs, right? So which one that f is less equal g or less g? Below here, right? This f is below this line equations, which means that in between this interval, that is our solution. Okay? So we can write the solutions within the interval. Since this is also equal in the g, so we need to include the number. Okay?
And then the last one. This is f. So we need to find between these two functions which one that has satisfy f greater g. So this is f. This is g. So when f is above g, that is actually our solution. So the solution is from this point and then from up until the negative infinity, and from this point to infinity. So we can write excluding the number because we are not equaling these two. So we have the interval negative infinity, negative half, and 3 to infinity. Okay, I hope you get it. Okay, this is very tricky, but when you get familiar with this, most of the cases that you will encounter in at least calculus. Okay, some part of calculus you need to get used to read the graph, observe the graph. Okay. So that's, I think, some examples to solve the inequality by using graphs. Okay. 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 Another one is about the increasing, decreasing. I think this is quite reasonable, right? So every time you see the curve is getting up, it's increasing, or getting down is decreasing. Okay? So you'll see that we can make sure that it's increasing or decreasing by taking the x1 or x2 and check the points, check the value, and we know that whether it's increasing or decreasing. Okay, so not much here. I can skip this part, and we may have what we call the maximum and minimum value. So the local maximum value, so this will be, so local max is when the f at a is greater or equal for the whole functions. Okay. So local minimum here at b but what local means? What local means? Perhaps it's not representing the whole graphs. It's only like a typical for example, if I have a graph like this, not really getting some, but maybe let me draw the axis first. Okay, maybe this is okay. So we have at least this point. Oh, why it's getting me? Okay. Okay, this is maximum, minimum, right? Maximum, minimum, maximum. The one that is the most. So let's say this is the whole graph. The whole graph from, so we are not defining any interval, but this is like, for example, this is a whole graph. The highest one we call the global max, and the other maximum we call just local. So local on that some interval, like a small interval beside the local. Okay. All the local, and the lowest one we call the global minimum. And the other one is just local minimum. Okay, you will learn this in detail in chapter 4 calculus. Okay, about this maximum minimum. For now, we just know that okay, we have the maximum value, local maximum value, local minimum value, and every time we see the graph, we can pinpoint the coordinates, and we know that. Okay, or if we have the quadratic formula, we know how to get the local maximum or minimum. Okay. Or you say the vertex, sorry, the vertex. Okay, I think we can skip some parts of this one. Okay, that's local. I think, can you draw the linear equations? How you usually draw the linear equations?
How to draw?
Yeah. How?
Like
Mm-hmm.
put values in it.
Yeah, put values. But my suggestions. Okay. So let's say this is this right. So let's say this is the y 3x plus 2. Right? So the way I did it is taking x equals 0, and we get the y equal 2. Okay. So by getting this, then we know that there will be a point that is around maybe this 1, 2, this is 2. So this is 0, 2. And this should be, the line should be having this point, right? And the other part is when y is 0. So we have 3x equal negative 2, which is negative 2 over 3. So x of negative 2 over 3 may be, it's negative 1, maybe around here. So I need to connect these two lines. So that's how I get the line equations. Do you think it's fast? Okay, so you can just use that. Okay. Just check x equals 0, y equals 0, and then connect it to the points. Okay. Rather than x equal 1, x equal 2, and then you put points. Okay. Just take 0. Okay. Yeah, I think my line is not proportional, should be like this. I think. Yeah, but I think it's the same. Okay, that's the how to graph linear equation, just some suggestions. Another part of the function is to transform the functions. Okay? The first thing, we can take the shift vertically or horizontally. For example, if we take the vertical shift, we can plus with the constant or minus with the constant, which means we shift upwards, downwards. For example, this one here, we start from x squared. Okay? We can plus 3, which means we move these functions, the same functions, upwards 3 units, and then x squared minus 2, we move it downwards 2 units. Okay, so I think very clear, right, for the vertical. But for horizontal one, this is a little bit interesting, because remember that if you want to maybe take a break, you want to take a break or move forward? Early, finish early. Suppose that we should be finished around, forget, 11, 10, right? Or 11, 20, 11, 10, right?
11.
So I think we can finish before 11, okay, before 11. So within this horizontal shape, so if you want to move like some constant to the right, what we did is we take the x and then change the x into x minus c, okay, to the right. It's a little bit different from the vertical, because the vertical we directly plus or minus the functions, but here we plus the minus the variable. Okay? So it tends to be a little bit different. It's not x plus, although that maybe in your mind this is positive, right? So it should be plus. But remember, it's not a function. This is the variable, okay? So it's going to take it differently. And then in the same way, if we go to the left, we get x plus c inside the f. So this is the example.
we take the x squared, and if we move to the right 2 units, it means this x, we substitute with x minus 2. Same thing with the left one here. If we want to move 4 units to the left, we get x plus 4, and then square. Okay.
Okay, I think that's it. This is example how we can. So the idea is finding this f. So finding this one here, which is square root of x minus 3 plus 4. So you could think this from square root of x, okay, and then you take square root of x, make it into x minus 3, which is so square root x, move 3 units to the right, okay, and then we can take this into plus 4. So this means move 4 units upwards. Okay. Okay, I think it's okay now. And aside vertical shift, horizontal shift, we have the reflections, okay? Reflecting the graph, okay, through the x-axis or through the y-axis.
So if you would like to reflect through the x-axis, we just multiply the function with negative. Okay? If you would like to reflect the functions with the y-axis, we need to multiply the variable with the negative. Okay?
Okay, a little bit more, and then we can have some more practices. Okay. So, what else do we have? Okay, so another transformation is we multiply with a constant. Okay, we multiply with a constant. For example, you can think this as we have y equal x squared. You can imagine if we multiply with this and we will multiply with 1/2. Of course, the graph will change. Okay, it's like a shrinking and then stretching. Okay, so if we multiply this with the constant, and if the constant is at least 1 or greater than 1, then we can see that it's going to be stretched like this. Like you have like a rubber band, you are making like longer and longer. But when you are having the constant between 0 and 1, maybe 1/2, 1/3, or any fractions, then you will getting a small, or if you can think like in physics, it's getting a smaller amplitude. The more you have the constant, like 1/2 and then 1/3 is getting like lower and lower and lower. Okay. So it will be shrinking. Like this one here, we get the x squared. That's our original graph, and we multiply with 3. It means that we make it longer, so it should be a little bit going to the left. Okay? So you can imagine like a stretching with the rubber bands. And if you multiply with 1/3, this will be shrinking, okay? Getting lower. Or if you are like usually if you feel confused in the exam and
Yeah, usually students do that, right? You can try to point some points. Like maybe it's like another function that asking you what will be the transformations. Describe the transformation, which means you need to describe whether it's shrinking, stretching, moving, shifting, blah blah blah. You can think like any function that you can draw easily, like x squared or maybe square root of x, or any function that you can think easily, and you can just multiply them and check the points. It's the points getting higher and getting down. You can think, oh, it's stretching, oh, it's shrinking. Okay, as easy as that. Okay? If you feel like you kind of focus and then maybe you're getting more and more anxious, you just try some points, okay, for some simple functions. Okay. Do not try immediately the question. Maybe the question having square root something x minus 4 plus something blah blah blah. That would be very difficult if you are trying directly from the questions. Okay. So this is vertical shrinking and stretching. There are another case which is horizontal shrinking and stretching. Okay. So we multiply the constant with the variable. So it's not the functions, but it's the variable. We'll multiply c with the x. Okay. So if the c is greater than 1, we are going to see that it's going to be shrinking. It's going to be shrinking horizontally. And this will be stretching horizontally. If c is between 0 and 1. And again, if you feel anxious, try some points and then check the point. Okay, try some simple functions, try some points, and then you can make your own conclusions. Because this is something that you don't need to memorize. You memorize this, like if you have a laptop, sometimes you don't want to save some files because it makes your storage full, right? Yeah, it's like that. So sometimes, maybe not really, but maybe the fundamental concept, you need to make it like a RAM that should be easily to access and then shift it in your brain. So sometimes like when you need it, you can pick up easily and then, oh, this, and then you can derive that by yourself, by your own. It took probably years of practicing it, but actually every human being, although you have like a different taste, different passion, but the standard level of math, I think everyone have a potential to master. Have a potential to master. So if you think like, I don't have gifts in math, it's not an excuse to learn math. Okay? Math can be learned by everyone. Okay? As long as you keep your consistency, you can learn math. Another interesting idea is the even and odd functions. So even and odd functions, I think the best way to explain this is by taking the two functions or observing two functions, which is the first one is probably, or let me write not here because it will be confusing. So maybe here, so y equal x squared, and the other one is y equal x cubed. Something that you can easily relate. X squared is like that, and then x cubed is like that. And this is a pretty simple example to show what is even function and odd functions. Even functions is, you will see the symmetrical like this. This is symmetric to y-axis. The odd functions is also symmetrical, but it's symmetrical to the origin. So how exactly symmetrical to the origin? I think I explained like early in class today. You could reflect this through y and then reflect it through x. Okay. So negative x, or x, y here, negative x, negative y here. Okay. So what does the even and odd says in this theorem is basically when you plug in negative x, the even function is going to be a positive. Okay. And for the odd, it will be a negative function. Okay. So if you want to check the functions, whether it's even function or odd, you can exchange the x with negative x. Okay? And then if it's going to be the positive f, then it will be even. It will be negative f, then it will be odd. But there will be another option which says that it's not even and also not odd. It can be. So it's becoming another function g, then it means that it's not even function, it's not odd function. Okay?
For example, if you have the x5 plus x, we can check this taking the negative x inside. So this will be negative x5, right? And then negative x. We can say that this is negative f of x, right? So this is odd. Okay. How about we have 2x minus x squared? Okay. So we can check taking the negative x. Ooh. And then this will be negative x squared. Now, what we can do now? Oh, I'm wrong. It's negative, right?
Well, we can take the negative.
Hmm?
Maybe we can take the negative.
So negative 2x plus x squared. So if this happen, then don't worry. We can say not odd, not even. Yeah, just that. So if the question is asking even and odd, and if you get the conclusion that is not odd, not even, so you can just write it's not like odd, not even. Okay. Sometimes, because I think I also have that kind of mindset when you have a question that you need to have an answer. If there is no answer in that question, just write down no answer in this question. Okay. Maybe because we getting used to like exam and questions in math that need to be computed and has some numbers, and we are actually getting used to all the going to high school or going to somewhere, you need to have a test, blah blah blah, and then you force out the answer by maybe faking out the equations. That's not a good idea. Okay. So that's transformation. So that even and odd functions. Yeah. Okay, another part of the functions is we can combine the functions. And I think this is pretty much intuitively we know all of this, and you already using all of this already. So you can combine functions, right? We can combine, and if you look at the graph, we can also make some observation. So we can, let's say we are going to plus these two functions. Okay? This is f and g. So this is f, this is g. So this is g, this is f, and then we add another f here, which are going to be taking all this part here, and then we somehow translating these functions into all these new coordinates. Okay. Okay. Okay, and I believe the one that is related directly to your calculus is this composition. Okay, so the compositions, if you have this H that is f of g of x, or sometimes we write f o g of x, or compositions functions. Now suppose we have g as x squared plus 1 and f is 6 squared of x. So if you want to write that h of x is f of g of x, which means we are going to put the x squared, we're going to put inside the f. So g, which is the x squared plus 1, going to put inside f and getting this output. Okay? I think it's quite easy to understand the process, right? So we can write this as a conclusion. Okay? So f of g of x. And it can have more than, like, this is only 2 composition. We can have more composition, like 3, 4, 5, okay? Because the fundamental is still the same. Okay? And the way we recognize the composition is also important. So if you're familiar and then getting used to these compositions, I think it will be very helpful, especially when you learn the chain rule in calculus. If you're still struggling about the chain rule in calculus, okay, you can think like one by one, taking parts of the functions and maybe defining each component inside the whole functions. Like how many functions that you can cut. Okay. Maybe there will be more than 3, maybe more than 4. Okay. Okay, that is the composition functions. Okay, another one, and I think this will be the last one, I think, is the one-to-one function and inverse. So first is we have functions, and then the second we have a condition what we call the one-to-one functions. So one-to-one functions, we need to assign all the x with all the y exactly 1 by 1. But that, so if we have this, like we usually have in the y equal x squared, okay, when you have like 2 and negative 2, it's becoming 4, right? So we say that it's not one-to-one function because 2 value of x is becoming 1 value of 1. So it's not one-to-one. Or I think the best way to look this is by taking the horizontal line. So if you have this random function f, and you take the horizontal, and if you getting 1, 2 point here, more than 1 point, it means that this is not one-to-one. Okay? So this is not one-to-one. Okay, not one-to-one. So we say that this is, we are taking the horizontal line. So if it is more than 1, it's not one-to-one. So it should be exactly 1 point. Okay?
Professor?
Yes?
Excuse me. We had some kind of conversation, some kind of dilemma in the first calculus exam about the difference between horizontal and vertical line. Because in one of the TE classes, we misunderstood which one was it. So, is there a difference between one and the other?
Yeah, vertical line. Vertical line is, so let me write here. Vertical line, this is to determine function or not function. Horizontal line is to determine one-to-one function or not? Okay. Like for example, let's just simply using our like a simple functions or ways. Okay. Why? Let's say we have this functions. Maybe you can say this is the y equal x squared. Or maybe we write with the f. Let's say this is our function x squared. Okay. We know this is a function, right? Because we can simply take this line at every point and it's exactly 1. So we say that this is a function. Okay? But if we take the horizontal line and we see that everywhere within these functions, it's always getting at least 2 points, right? So this is a function, but it's not one-to-one. Okay? So we say this is a function, but not one-to-one. Okay. Okay. Okay, so one-to-one. And one-to-one functions is the requirement for a function to have an inverse. Okay. So we say the definition. Okay. So if we have one-to-one functions, okay, with some domain A and a range B, then the inverse will interchange the domain. So the domain become range and range become domain in another part. Okay. And we define this by these terms here. So y equal f of x, and then the inverse, this will be equal to f inverse y equal x. Okay. For any y in B, or if we take this graph here, okay, the picture, usually we take x as our variable, we put into our f, and we get the function. So the inverse is actually taken from here and put into another machine that will give you the variable. Okay, so that's the process. But sometimes we are getting confused because we already set our mind with our y and x at the beginning. So when we make some process, we are kind of mixing of x and y. So as long as you keep consistent defining the x and y, you should be able to determine, like, if you have a function, then what is the inverse? Okay? So basically, how to find the inverse, or maybe before we find the inverse, every time we have an inverse and an f, if we put f of x inside the inverse, it will get you the x, as we did in the picture. If we put the f inverse into f, this is also the same having the x. So the way we check whether the function is having an inverse is we check the inverse, put back into the function, or we put the functions, put back into the inverse, whether it's getting you the x or not. Okay? If you're getting the x completely, then that's the inverse. Okay? So this is the way you check. We check the whether the inverse is satisfied or not. For example, if we have the f of x is x cubed, and then we have g of x is x with power of 1 over 3. Okay. We can check this by taking into composition function like this. So we take we take the cube and then it's becoming x. So it's an inverse. So G or F is an inverse of F. So the way we find this inverse technically, okay, practically, so first we write in terms of y to make it simple. Okay, so if you write it within f, maybe not good for your equations. So write y f of x. So let's say we are taking the y equal x cubed. Solve this equation for x. So x is square or roots of cube root of y, and then interchange x and y. Why we need to interchange? Because remember that we are going to change the domain and range, right? So this is y now becoming this. This is the new y, the different y from the previous one. So we say that this is the inverse. Okay, another way to graph or to check the inverse is taking the graphs. So the inverse is actually, we can observe through the reflections about y-axis. So you have any functions, you draw the y equal x, and the inverse is on the other side. Okay, you reflect the functions. So that's why, if you remember, if we have the x squared, okay, if we have the x squared, like this, we know that this is not one-to-one functions, but we still have an inverse for this. Let's say we are going to cut in half. Okay, we cut the graph, so we are only having this part. Okay, so we draw the y equal x. So this is x squared, and the inverse is practically that. Maybe not really good. Yeah. So this will be y equals square root of x. Okay. So you could visualize the inverse easily by taking the y equal x as your center for reflections. Okay. So I think we can have some exercise. Let me check the okay. Okay, solve the inequality. We're back to this solve the inequality. I think the first one easy, right? Do you think easy? So basically we take 2x. Let me just solve for you. It's -4, -2, right? And then x. Who's still struggling with this inequality? Anyone? No? It's okay if you're still struggling. Then we can have some more practice. How about number 2? Can you check it? Okay, maybe it's annoying. Okay, try number 2. Meanwhile, number 3 is easy, I think, right? Do you agree? Number 3 is easy. So we can take the x minus 5 less equal 3. But I think it's also in, let's say you try number 2 and number 3. Okay, try number 2, this one. So we have x minus 4 over x squared minus 4 should be less equal 0. Okay. Do not multiply this. Oh, we have x equal. The x less equal 4. Remember, you already have learned about domain and sort of things like that, right? So you have some restrictions in the interval. So every time you have inequality, the expectations is the solution will be in interval, usually in interval, right? Which means that you need to find on which interval that is satisfying this equations. Oh, this one, right? So this absolute value. Remember that the absolute value, if you have, for example, absolute value, let's say less equal some constant, this means that we are going to have this. We can think maybe from this part, and then we have x and then negative c, right? So since it's negative, should be that. So we need to correct this. So I think number 3 being okay, right? So we can just write like this. Okay, number 2. You get number 2. Okay. Well, how do you get minus x squared?
Professor,
Why is equal?
remember you said that we can like treat the number 2, which is a fraction, like an equation. So we can like it's done over like
Yeah.
we can like put it like on the other side.
Remember, if we have this fractions, the one in the bottom, if you want to make it true for all numbers, you shouldn't make it equal to 0, right?
Yes.
So there's a restriction, which is actually it become affecting the interval of the solutions.
We can do some solutions.
Yes, yes. So you need to make sure, yeah, observe the yes.
My turn. Jose was the one that was doing it.
Yeah, take tactic. What was that?
infinite canvas? How about this one? I said that you cannot multiply that. I just said that in the front, you cannot multiply.
We can factorize.
Yes.
We can.
Yes, yes, we can
Exactly.
factorize, yes. Okay, so I think we need to improve our mindset. So math problem, sometimes you don't need to force out like to compute everything and find the numbers. What you do need is we need to observe things from here. This denominator, x squared minus 4, will be true and defined for the numbers if this is not equal to 0, right? Okay, so if we try to let's write and let's factorize this. We can factorize, right? Just write like this. Okay. As I always mention, yeah. Okay. So as I always mention, all these components become important. It's all become important because in this case you cannot have x equal 2 or negative 2 because it will be 0. Right? So everything that is here and also this one because this is already 0, so we can, if we just look at the top, we know that x should at least 4 to make it 0. Right? So we have 3 points. We have 3 points that we need to consider. We have negative 2, 2, and 4. And then we can check one by one. Check negative 3. And negative 3 is negative. Do not care about the numbers at all. We only care about its negative or positive. So negative, negative 3, negative, negative. So negative, 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 positive, negative, positive, negative. Right? Negative. And between negative 2 to 2, let's try 0, the easy one. So 0, negative, negative, positive. So it's a positive. And then between 2 and 4, let's try 3. 3 is negative on the top, positive, positive, so it's negative. Try 5. 5 is positive, positive, positive. We want the last 0, so we want the negative one. So this and this. But we are not done yet. Okay? We need to make sure whether we need to include the numbers or exclude the numbers. For negative 2 and 2, can we include this inside here? No, right? Because it will be undefined. So that's why we need to write this is like that. 4, we need to include that 4 because it can make it 0, which is satisfy our equations. So we can close the interval like that. So the solution is we can write negative infinity to negative 2 and also 2 to 4, but we need to include. If you make it like just like a open brackets like that, then the solution is not complete. Okay. And you will see something like this will happen in calculus in chapter 4. You learn about when you have the slope
and you need to make it 0, and then you are going to see whether it is going to be positive, negative, and then you will have this kind of solution as well. Okay, that's inequality. Okay, so the important thing is how to set the mindset for observations. Okay. Okay, another set of exercise. I think it's easy, right? The circle equations. Okay. So let's check if you are still remembering how to get the circle equations, getting the which one is the center, which one is the radius. So remember how to find the center and radius? Yes. You can start with just a normal circle, like x squared plus y squared equal a constant or radius squared. Right? So we need to make it this equations make into that equation. So it could be x minus something squared plus y minus something squared equals another constant. Okay, it's okay. You don't need to class. Okay. Okay, what is a circle? I'm not sure which one, because there are several plans. But do you think it's working? I think that one is turning on. Maybe this one. Yeah, I think it's already turned on. Oh, in my place. Okay, so idea. Okay, again, let me make this clear for you. The way we have a circle is this equation, right? This is we say the normal circle, which the center is at 0, 0, right? And radius is r, right? Okay. So if you want to shift the circle, then we can shift by taking. Usually it's h and k, but you can have a different variable if you want. But let me just write with h and k. So the center now is changing to h and k. Is it the same circle? The same circle, but we move the circle to new center. So basically, when we are given with these two equations, which simply stated all the numbers of quadratic x and y, and it has all this x, y, we need to force out making these components. So basically, we are going to group all the x and all the y. Okay. So taking x and y, so we can write, let me make a space there, and then let's just write the 9 to the sides, to the right side, like that. What we are going to do is we are going to take the standard form for the quadratic equations. Okay. So this will be plus 1. Remember, if we plus the left equations, we need to plus the right equations. Okay. And then we need to take another one with the y. This will be plus 9, right? So we can write x plus 1 squared plus y minus 3 squared, and this will be equal to 1. So what will be the center? The center is -1, 3, radius is 1. How about the second one? Try the second one. Try the second one. Try. The same concept. Oh, you get this one? It's from 6 divided by 2 and it's squared.
Porque si agregaban un lado,
You can switch like from here. You can square.
¿Sabes qué es?
porque tenés que buscar un número que cumpla un trino se cuadra, un trino se cuadra perfecto.
Pero por usar el uso. No puedo poner.
Kita sehari angkanya berapa waktu kita bikin dulu tapi kita buat dulu yang lebih gampang lagi
Y esto con los,
dibuat
y aquí va a ser 3. Entonces ahí tienes 3. Porque esto que el primero, o sea, la cuadrada con el primero más el doble primero con el segundo. Entonces si dividiste con 2, vas a poder tener el segundo, que va a ser 3.
jangan ditambahin.
Can you tell the professor what kind of word you told me in Indonesian?
Iya,
Yes,
apa?
you did.
Minus 9 is from the plus 9 on the top. Move to the left. Y kuadrat. Yang merahnya kan udah tulis. Sekarang saya tambah. Iya, saya mau langsung bikin kuadrat menghasilkan apa? Saya mesti tambah apa? Caranya gimana? Yang dua tuh dari dua di kuadrat tambah satu. Kita tambah satu di kiri, kita mesti tambah satu di kanan. Oke, satu lagi. Yang 6 itu 12. 3 kuadrat kan 9, saya mesti tambah 9. Tambah 9 sama. Oke. Sehingga saya bisa kuadrat ini.
Sí, creo que raíz no sé. Sí, raíz no sé.
Pero you see,
Vamos, yo tinggal Okay. Yeah. So what happened if we have radius 0? So it's only what? Yeah. Right. It's just a point, not a circle, but a point. Yeah. Correct. So this one is interesting because it's not a circle, right? It's not a circle. It seems like a circle, but it's not. So we get the same formulations. And I will put negative 34 here. Okay. So this will be plus 9, plus 25. This will be plus 9, plus 25, which is 34 minus 34 is 0, right? Which means that this will be x minus 3 squared plus y minus 5 squared equals 0. So it's just a single point, just a point of 3, 5. So just a point of 3 at 3, 5, okay? Not a circle, okay? Because the radius is 0. Okay? Just a single point. Okay? So this is a single point. So single point. Okay. Okay, more to come. I've prepared at least 3 more pages. Okay, try this one. We have line equations passing through some points, and then we have another questions. Line passing through a point, and then it's perpendicular to another line. Make it smaller a little bit. So this is actually cases for, or maybe basic concept for most of the tangent line equation problem in calculus. In calculus, we take the slope from the derivative. So this giving you already the points, even the slope already here. I think number 1 easy, right? You can just take the points and then compute the slope, right? So the slope is -4, negative, -6. So we have the slope is 2/3. And then we can take the slope and put back into the equations. We can choose between 0.1 or 0.2. They will be the very same line. So let's say we take the 0.1. Okay, so y plus 1 equal 2/3, and then x plus 6. Okay. So this will be y 2/3x plus 4 plus minus 1, so plus 3. So that's the answer. If you would like to check the other one, that's also fine. Oh, wait. I make a mistake. You take the notes? Sorry. So y plus 6, and then this will be x plus 1. Okay. Two over 3 minus 6. 2/3 minus 6, what will be? Minus 16/3. And then the other one, same, right? Same.
Why is 16/3? Minus 16/3.
Yeah.
Why?
What? Because compute this. Minus 4/3 minus 4. This one, 2/3 minus 6. Minus 6. Okay.
Okay, how about the second question?
The answer is
What should we do first?
maybe we should like
Yeah, slope. Slope from the second one.
For usually
no, ada langsung iya itu kan langsung malu
Why?
isi segera tes
Yeah, why you do it? Oh yeah, it's number 1. You check number 2. And you do number 2. Yeah. Yeah, that's not too good.
Oh, asumiendo nuclear es una acción nuclear. Entonces no siempre son 16. Me parecía muy raro, muy feo.
What does it mean? Yeah, but what does it mean? No, this name is product. Let me close this. Yeah.
Entonces, se va a creer que te dan.
But what's the implications? So you have the slope here, different another slope here. I think I mentioned that before. Yeah. So can you find the slope from the line? From the question? Look at the question. Can you find the slope from here? You're already writing. This is correct. So what you are going to do is you need to change this into this. Can you do that?
I don't know.
No. Focus here. Try to change this. From here, we need to rearrange this to make it into this. Do you get my point? From here, so what I need to do is write this is 3-1, I will write 3-1 on the right and move everything to the right side. So it's negative half. You get it? I will divide by 3. So I will this. You get it? Now I have this. What is this? What is this? Focus here. What is this? You really write it. You have M1, which is the slope. It says that the slope is perpendicular. What does that mean? Yeah, this one, right? So M2, okay, which is equal to? Can you compute this? Can you compute this? Can you calculate this? One divided by 1/3.
My answer. It's only like M, right? M5. Where did oh, listo.
One 5 0
Listo also means smart. Like you are only listo if you are very smart.
2. Okay. So this will be
Yes.
Okay, so first finding the perpendicular is basically from this part we are going to take 3y equal x plus 16, right? So y is 1/3x plus 16/3. Okay? So the slope is 1/3.
That's right.
So 1/3. So let's say this is our M1. Okay. So M2 is negative 1/M1, which is negative of 1/1/3, which is negative 3. So that is our slope that is perpendicular to the line. Okay. So, based on the point, we have y minus 7 and then x minus 1 like that. So we can solve 3 plus 7 is 10. I think we've finished.
That last part, I really understood very well. That last part.
Which one? This one?
Yeah, no, that I got it. But the black one. Yeah.
Y minus 7.
Yeah, 1 minus 7.
Yeah. Minus 3 and then x minus 1.
And minus 3 is the M.
Yes,
Which is logic.
Okay.
And that's the formula I said, the line.
This one?
No, the last one. The answer is the
Yeah,
the point. What is it?
I don't know what you are asking.
God is what?
We find the equations. Oh, we need to graph a line, but I think we can graph a line. But we need to find the equation. It's okay?
Yeah, but for graph is my question.
Oh, for graph?
Yeah.
I think we can graph. I think we can graph the second
What's
one.
the final answer?
Like for example, we can graph. Let me erase this part first, just to make a graph. So we take x0 is y is 10, so this is 10. For obvious reason, this will be not proportional. So y equals 0 will be 3x. So 10 over 3. 10 over 3 is 3 something, right? So let's say maybe over here. So this will be okay, something like that. Okay. But of course, this is not proportional to be like that.
And the other one, the perpendicular will be this side, right? Will be like the other color. Like the 3y plus.
Yeah, this one is here.
Yeah, but that's the perpendicular.
Oh, you mean this one?
Yeah.
Yeah, you can check. So 16 over 3 should be 5. Will be here. Will be here. And the other one maybe here, right? Maybe yeah, like that. So maybe about that. Okay. Okay, another questions. Okay. So solve these equations and equality by graphs. Okay. This is the same problem that I gave you before. Of course, if this is equal, if this equal means that it is perfectly on this point, this 2 point here, right? And by the graph, we can observe the points directly. So let me just write the point. This point is -1. This point is 2, 3, 4, 5, 6. Okay. So solution for the first one And you can solve this by solving the quadratic equation in the whole. And you can get x is -1 or x is 6. And then you have the last equal, means that the red curve need to be at least below the line equation, which is between this interval, right? So we get the solution for the second one,
Right.
right? Okay. And then the last part, the red above the line, right? The line with blue, which means that from -1 over there to the left and from the 6 to the right. So we can write okay. Okay, what else do we have? I think should be okay this one. Okay, domain. Okay, which one you want to try? I think the first one easy, right? No or no? The second one also I think simple. But be careful, number 3, it has a cube root, okay? So it's not a square root. Okay, number 1, this is, we can say that x plus 1 need to be greater than 0. So x is greater than -1. So this is the domain. Our domain is and number 2 also, x should not be 0, x should not be -1, x should not be -2. So you can write the domain x as x is not equal 0, x not equal 1 is -1.
Professor,
Yes.
for the first one, another answer can be that the domain has to be like square x plus 1. It has to be like greater than 0.
Mm-hmm.
So maybe the domain x like this. It has to be like
What do you mean?
Yeah, or this x is always greater than -1. How about the third one? The third one, we have a cubic roots. Can it be negative inside cubic root?
Oh.
Yes.
Can, right? Yeah. So for all x inside the cubic root, we can have all x, right? From negative to positive, you can.
All the
So the only way
So
we can do is the
doesn't have to be zero. The
Yeah.
part that is
this part should not be equal to 0.
the x,
So
the root function, the root part of the part, so that
should not be equal to negative 2, or this one should not be equal to negative 8, right? Or x is not equal to negative 4. So domain is so our schedule actually like we have Monday class Monday class 9. I will continue to the next chapter, the polynomials, and then we have what the so that will be 16 October, right? And then we have 23rd. We'll continue whether if we finish polynomial, we can continue to another one as well. But for the next Monday, 30, right? 30 of October, right? So for the 30th of October, we're going to have a quiz. Okay? But the quiz will be only from the fundamentals and function only. Two chapters.
the last two chapters. The first two chapters.
Yeah,
First two
up
chapters.
until functions. Up until
Until
functions.
function.
Until
So
functions.
everything.
So everything until functions. And then we have another class afterwards. After 2 weeks or 3 weeks, or maybe through 2 weeks, we have another quiz. But if in the process, we may have like several quizzes. Some of them may be like an online quiz that you can prepare your own notes, and I think you can do with your own pace. There will be no midterm. So only quizzes and finals. No, not next Monday, not next. The 30. So this will be quiz, fundamental, and function. Okay, now so suppose the graph f is given. Well, I'm not giving you, but I mean you can draw it randomly. What you're going to do is, if you have given this 3 different cases, how you describe this curve based on the f. For example, whether f you describe as you want to move this f shifting upwards some units 1, 2, 3, right? Or maybe shifting downwards, or maybe shifting to the left, to the right, maybe shrinking horizontally or maybe vertically. So that is the expectations. So you need to describe by words how would like to happen. Okay? So for example, this one here. So for obvious reason, if you plus 1 here, so you should be moving upwards 1 unit. Okay? And then you multiply 2. So what happens if we multiply by 2? Is it stretching or shrinking or whatever? So that's the expectation. And do the same thing with the other question as well. Okay? And then, like I said before, if you are maybe lost in thought, maybe in exam or in other problem as well. You can let function f be some simple functions, but not too simple. Like if you just put linear equation y equal x, it's not describe anything, right? You can put something like have a curve like as x squared, okay? That's, or maybe the square root of x also can be done, okay? Okay, try to think first how to do this. You can think f maybe x squared. So if you have a x squared like this, if you multiply x squared become 2x squared. So when you plug in the number, you will see something change, right? The points keep getting up, right? It means that the new one will be maybe here, right? So the first one, let me give you the first one. The first one is shift, or maybe stretch first. Stretch f vertically with factor of 2 and shift upwards 1 unit. How about the second one? The second one. How you should shift? So either way, like you shift horizontal first or vertical first, it should be the same. Yes. You get it? So we have like a random map, and then if we take f and then random, we get this equation. What would be the transformation? So this equation is you need to write within some words. Okay. Second one. You can start from anywhere. You can start from this. You can start from here. The same conclusions. If you start from here, then you remember if you have x minus 2, it's inside the f, right? So we are going to move right, 2 units, and then we have minus 2 here. We move 2 units down. Okay, get it? Okay, maybe let me write like in a very simple words here. F move right 2 units. F move downside. Okay. And how about this third one? Yeah, reflection. We can start from anywhere. We can start from reflect with y-axis first and then x-axis, or x-axis first and then y-axis. The same conclusion. Okay. So F reflect about x-axis. Then reflect about a y-axis. The order doesn't matter. Okay. In any order, the conclusion will be the same. Okay. Okay. Okay, I think this will be the combinations, the compositions. Should be okay, right? Composition. No, try by yourself. Why? I give minutes. I think it should be enough to look for. If you keep going, just taking picture without getting the concept, it's useless. Actually, in my class, like, if you think that you don't need to write the notes, then it's okay. As long as you get the fundamental concept, it should be fine with me. Okay, I think this will be easy to understand, right? So, which means that this one is, we are going to put f inside the g. And if we have this, then we start from the right. F put inside g, and then the whole thing put inside f. So we can write this as a g f of x, like that. And then this will be f g f.
It's just that. That's it.
Hmm?
Or we have to
That
put,
last one should be like that too.
or I have to put square root of x minus 1
Yeah.
side.
Yeah, and then you can yeah, this is the example. Okay, so we can put the example here, which means that this is going to be f is 1 plus x squared. So this, let me write this first to get the process. So this will be square root of, so 1 plus x squared, we're going to put inside the x, so 1 plus x squared minus 1, or this is just x.
1 plus.
Maybe better to be absolute value of x. Okay.
If we put like,
See,
it's because everything is going to be positive.
Yeah.
Professor,
Yeah.
Are we going to lose point if we just like forget to put like
Absolute value.
absolute?
Yeah, it will be not complete. Yeah.
There is not much points, right?
depends on the cases. Okay. If it's like a minor cases, maybe you still get the more points. Okay. As long as you get the most problems. Okay. Like if the question is asking mostly about like a calculus part, as long as you get the idea of calculus part, then it should be okay. If you get like a miss out some number or even some absolute value, you still get most of the point. Okay? Because the idea is the process of the calculus. Okay, now the second one is going to be f put inside. So let me write f. So we already did before, like the absolute value of x, and then we put inside the f. So this will be, or this will be back, right? So it's back to the f. And if you have the number, then we can just plug in the x equal to. So this will be f g of 2. Okay, if you plug in the number, at least there are two ways doing it. You can plug in first the functions and then later plug in the number, or plug in the number first to the first equation and then plug into the second equation. Should be the same. So if you plug in number, for example, if you get the g of 2 is become 1, so you could get the f2 is 2, right? So FOG2 is 2. Or you could find first the functions. So we could take this 1 plus x squared minus x, which is the absolute value of x.
Why is why is 2 the F?
No, just it's a question. You mean
Like if we plug 2 into the first equation, it's fine.
because the conclusion is the same. So this is 1, right?
Yeah.
If you plug in 1, okay? So g of 2, 1. So I would like to put g inside the f. So I'll put 1 inside here,
Yes.
1 from here. Then it's 2. 1 plus 1 is 2. Okay? Is that?
Where is their parameters?
Yeah.
Wow.
Coincidentally, they are the same. The FOG and the F of 2 is the same. 2.
F of 2 is 2.
Yeah, F of 2 is 2.
That's
Not
about-
sure, right? So check this one. Okay. Put here, we get the absolute value of x, right? Which when we put the f, when we put the x equal to, is 2, the same, right? Okay. So you could put the number first, you
Yeah,
get the
that-
result.
Yeah, that's
You
fine.
put the result inside this.
F of 1
Yeah.
is 1 plus is 2.
Oh, this is 1. Sorry. I know. I know why you're confused.
You thought I was correct before?
Yeah. Yeah, sorry.
That makes sense.
Okay. Yeah, I also don't know why I'm putting 2 there. Last one, okay. I think I give you, I think easy, right? This one. Find the inverse of this 2. And then we can finish. Okay, I think quite easy, right? I think I will just go directly write this y, and we solve this, and solving, or maybe let me write and then interchange back to the inverse part. Okay, we get the first one.
First one.
Or if you want to write maybe half 3x minus 1, this is also okay. Okay, the second one, then we can take that. How to getting this one. So x plus 1 is roots of 5 of y, and then x is root of y. Okay, so we have the f inverse. Okay, done. Finish.